So here's your unit circle, and you can see it is filled in already with all of your radian and degree measurements. The first thing that we'd like to do is also add to this and label what all of these coordinates are for these special spots around the unit circle. We want to know what those x and y values are. And so that's going to be my first step. And since we're on a unit circle, that means that moving out from the center to the points along the axes have a unit of 1. And so that's the first step. Those should be the quickest for you to label. And you do want to start going for speed. You don't want this to take a lot of time. And now this quadrant up here in the first quadrant, this is considered my reference quadrant, because whatever happens in the first quadrant happens all the way around in the other quadrants, just changing the signs. So now we've looked at previously how to find these coordinates based off of the special triangles, but I'm going to show you a shortcut to being able to create these coordinates right here. So there's a pattern. So the first coordinate is 1/2. The second is root 2 over 2 and root 3 over 2. So notice that they all have a denominator of 2, and the numerator is the square root of 1, square root of 2, square root of 3. So we don't write the square root of 1 because the square root of 1 is 1. But you can look at this pattern. So if you can always remember that the denominators are always a denominator of 2, root 1, root 2, root 3, and then work your way backwards with the same pattern. 1/2, root 2 over 2, root 3 over 2. And so the pattern is one direction, and then you write the exact same pattern going in the opposite direction for the other part to your coordinate. And that is your reference. So if you can make this very quickly, then now you can take that and flip it over and just change the signs. So since 1 pi over 3 and 2 pi over 3 are the similar increments, that's going to end up being a negative 1/2 with a root 3 over 2. Right? When this flips over, this becomes a negative root 2 over 2, right? And so on. And then again flips over. And so you can see that once I create that reference quadrant, when I flip it over, I can just change the sign on my x. Now if I take it and I flip it upside down this way, 5 pi over 6 and 7 pi over 6, those are increments of pi over 6, and so they have the same coordinate, just with another sign. So again, I'm going to write this coordinate down here, but now both signs are negative. The pi over 4 increment is the same as the pi over 4 increment, so that's going to be with the root 2's, both with negative signs. And again, the increments that are pi over 3 starts off with the 1/2. Okay. So do the same thing as you move along. So again, over here, the pi over 6 and the pi over 6 increment has the same coordinate, but the y values are negative. All right. And so as we start creating this graph here, it's really easy to label what the different coordinates are as you move around the circle. Right? And so you want to get in a good habit of quickly being able to label those based off of that pattern of going down with the roots and back up with the roots. So if you can remember this, then it's easy to flip it over and look at which ones have similar increments. And now what we want to do is we want to be able to utilize that to understand sine and cosine and the other 6 trig functions. And so now when you look at a triangle, I'm just going to use this one for a reference real quick. And this is your angle. This is 30 degrees. And this is a hypotenuse of 1. If I want to imagine a triangle in here where the length of the legs are the coordinates of the x and the y. So again, this is my x coordinate, and my y coordinate is the height. And so when I'm looking at this triangle, if I want to know what is the cosine of 30 degrees, I can look at the cosine as being adjacent over hypotenuse, and that's the same thing as x over 1. That means that when you're on the unit circle, your cosine of an angle is always the x coordinate, And if I wanted to know the sine, it would be opposite over hypotenuse, which would be y over 1, which means that your sine value is always the y-coordinate. So these coordinates that we have that are actually around the unit circle can tell us the cosine or sine value of any of these angles as we're moving around. Right? These are the most important because once you know sine and cosine, everything else is going to fall apart from that. Right? So we need a couple more little pieces of information, so I'm going to have us look at adding some general information to that right there. So let's look. I'm going to pull this up here. Right. And so with what we have now, we can say that the cosine of an angle is going to always be the x over the radius. And in case it's always x over the radius, which is the hypotenuse, when you're on the unit circle, you can just call it the x-coordinate. Right? The sine value is always going to be the y-coordinate. And if you think about how tangent works, tangent is always opposite over adjacent. So your tangent is going to end up being always y over x. And these are your standard sine, cosine, and tangent. You also want to be able to remember to use their reciprocals. So we're going to deal with finding these first and then the reciprocals after. So let's look at a little example, all right, of how we're going to use this information. And so down here, oops, kind of zoom out here. The directions at the bottom of this worksheet say to use the unit circle above to find the exact value of the 6 trig functions for each angle. The exact trig function, all right? So when it says I want to find the exact value, that means that we have to use all these values off the unit circle, and if it has a root 3 or a root 2, we have to leave it that way, right? And so we're going to look at different angles. Say, for example, we have the angle 5 pi over 4, all right? And for that angle, I want to be able to identify the cosine of the angle, the sine of the angle, and then again, the tangent. So we want to keep them in this pattern, cosine, sine, oops. Actually, you know what? Let's change that. Let's do it in this way. I think it'll be easier. Let's do sine, then cosine, then tangent. Right. There's going to be a method to that madness in a second here. So sine, cosine, tangent, and then let's write their reciprocals off to the side. Cosecant, secant, and cotangent. And so what we want to do is we first want to locate 5 pi over 4 on the graph. So right here. That has the coordinate of negative root 2 over 2 and negative root 2 over 2. And so we're going to use the information that we just looked at in terms of if I were to draw a triangle and imagine a little triangle in here. All right. So let's just do that. So if I were to draw a little triangle as my reference triangle, and I'm saying this is a hypotenuse of 1, this is my x-coordinate and my y-coordinate. And again, if I want to know the sine, it would be the y over 1. So I'm going to look at just the y value and say the sine of that angle is the y-coordinate, which is negative root 2 over 2. Cosine is always adjacent over hypotenuse, which is the other coordinate. And since tangent is always opposite over adjacent, I'm going to create a fraction with these two. And so this is my opposite, this is my adjacent. And so that's why I actually changed it and put sine over cosine, because if I just create a fraction with these two, that becomes my tangent. So because I have kind of like imagine this as the numerator divided by the denominator, or opposite over adjacent, that means that my tangent value is going to be 1. Now when I change this to cosecant, when I write the reciprocal, the signs need to stay the same. Right? But when I take this value and I write the reciprocal of it, what's going to happen is I'm going to end up with a radical in the denominator, which I'm not allowed to have. So I need to rationalize that, and that's going to end up giving me a negative 1 over the square root of 2. Same thing for this one. Rationalizing is going to give me a negative 1 over root 2. The reciprocal of 1 is just 1. And so this is going to be your process. You want to locate the theta, whether it's in degrees or radians, identify the coordinate that is at that point or at that angle, and start breaking up the coordinate into the different parts, cosine and then sine. And if you think about coordinates are always in order of the alphabet, it's usually an x, y. Cosine comes before sine because c comes before s. So it kind of goes in order of the alphabet. Right? You can do the same thing with degree measurements. Right? And they can be negative. So say I want, negative, negative 390 degrees. Right? So that's more than one rotation around the unit circle. Right? That means I've gone this way and then a little bit extra. So you really do need to know that extra piece, because what that's meaning is that I've actually gone all the way around and then an extra 30 degrees. All right, so what I've done is I've actually stopped right here at this 330 degree mark. So 330 degrees is coterminal with the angle that I'm given. And so you want to be able to find coterminal angles so that way you can identify them on your unit circle and make this process of finding the 6 trig functions easier. So coterminal angles and reference angles are going to really play a part in how to identify where we're at on this graph. Right? So if I know that I'm right here, right, the angle that we're still referring to is this negative 390, but since it's coterminal with 330, I'm going to use the information sitting at 330. All right, so you have to figure out where you're coterminal to find the coordinate that is in the same place as if I went around and then stopped at that point. All right, that's going to be super important. So when I'm looking at sine, cosine, and tangent, all right, again, you want to make sure that you can break up all of the reciprocals as well. The coterminal angle with the one we have terminates on the coordinate, root 3 over 2 and negative 1/2. And so again, the x value here is my cosine. The y value is my sine. And then when I create a fraction with this, really I'm going to show you what's going to happen. There's actually a cool little trick here. All right? When you take two fractions and you put them directly over each other and make a complex fraction, because of all this process of having to write the division symbol, and then you have to go through and multiply by the reciprocal, you're going to notice that when you have the same denominators on the fractions, they always cancel out. And so what happens is that this fraction that I get after I've done all this work is the same thing as if I just looked at sine and cosine and just get rid of their denominators and create a fraction with the numerators. Cover up the 2's and make a fraction where negative 1 is on the top, root 3 is on the bottom, and that's the same thing as going through all of this process. The only thing is that you have to rationalize. And so when you rationalize the denominator, it changes what it looks like, but this was what it looked like originally. And you're going to want to do that every time you do sine, cosine, and tangent. You don't want to necessarily go through all this work. You want to get rid of the denominators, create a fraction with the numerators. So let's look then at the reciprocals. All right, reciprocal of negative 1/2 is negative 2. Again, if I write my reciprocal of secant, I have to change that and rationalize. And then the same thing with cotangent. Cotangent is going to end up being a negative square root of 3 when I rationalize. Right? And so this will be your process. Right? You want to look at how to first use coterminal angles if necessary to identify the coordinate, break up that coordinate into their sine and cosine components, and use the other information to find the other 4 trig functions.